Hello everyone, I hope you're well and not too bored in your bunkers. Before going on to describe the May's skynotes, I thought I would show you the Society's solar telescope. Now when we eventually meet again, anyone can borrow this telescope, so I'm just looking after it at the moment. And if you look at it, you'll see that it looks like an ordinary refracting telescope. So you've got an objective at the front, a star diagonal at the back and an eyepiece, but there are some unusual features, and the most noticeable of which is this strange rotating device on the side. And the reason it's there is because the telescope contains three sets of filters. There's a filter at the front which takes out most of the ultraviolet and infrared to make it safe for viewing. There's a special filter in the middle called a Fabry-Perot Etalon, and then there's a blocking filter at the back and a normal eyepiece. Now the point about this screw plunger on the side is that when you screw it in, it increases the pressure around this Etalon. Now the Etalon just consists of two flat plates of glass, and the wavelength it transmits depends on the pressure of the air between the two pieces of glass. When you screw it in, it tunes the Etalon to the blue end of the hydrogen alpha line, and as you unscrew it, it tunes to the red end of the line. And the idea is that when you point the telescope at the sun and look through, if you tune it to the blue end first, what you'll find is that you probably can't see any features, but as you gradually unscrew it, then you'll find that the prominences will come into view, and then as you unscrew it even more, you'll be able to see the granulations on the surface of the sun. And the reason why you can see different features with different settings of the pressure is because of the Doppler shift of the light. Because the sun is always moving and the gas is always moving, different parts are red shifted or blue shifted. So if you, first of all, when you look through you can't see any detail, then don't panic. It probably means that you've got the wrong setting of the pressure. Now I've got it mounted, the telescope, on a simple camera tripod. What I find is that's totally adequate. You can even take photographs that way. You don't need a fancy go-to tripod. And the other feature is this strange contraption on the top, and all this is to find the sun in the first place, because there's just a hole in the front plate, and the idea is the sun shines through the hole and lands on the cup at the back, and you just line the telescope up so the light from the sun hits the centre of the cup and you know you're safely pointing at it. So as I say, once we're back at our normal meeting, then I hope somebody will take it off my hands and have a grand view of the sun. So here are the sky notes, and hopefully I'll see you next time. These are the sky notes for May, and I thought I'd start with this picture that Jeffrey sent me of the last full moon, a mega moon, because the moon was one day after perigee. And if you miss this one, I'm afraid you're going to have to wait until 2025 when there's an equally large one. At the other extreme, just after the next new moon, we had this very thin crescent that we could see low down in the west just after sunset, and it was one of the earliest moons that I'd seen, and it was only a day and 17 hours old at the time. I don't know what we've done to upset someone, but it always seems that lunar eclipses occur at lunar rise or lunar set, and the one this month on the 5th of June is no different. It's only a penumbral eclipse, so if you remember the last one where we tried to see it from our meeting, no one could actually see any change in the moon. So I don't expect that we'll be able to notice it, because yet again
it's in progress when the moon rises, so we'll only see the latter stages. So I don't expect it'll be a very grand sight at all. Turning to the sun, it's still very quiet with very little activity, but I managed to see these wonderful prominences using the Society's solar telescope on the 20th of April that shows two regions. One looks as though it's just become detached from the surface. I was going to say that the prominences were the only things you could see at the moment, but then Peter sent me this picture of a sunspot on the 26th of April, and in fact two more sunspots have appeared since. They're very small, and the interesting thing about them is two of them are from the new cycle 25, but this sunspot that Peter imaged is one from the last cycle 24. Well, the weather gods were on our side during April when we had superb clear nights, but the comet gods weren't with us at all, because the comet Atlas decided that it was going to break up. So this is a picture that Jeffrey took on the 4th of April, where it's nice and bright, and we're all thinking, oh, it's going to be superb. And then come the middle of April, when I took this picture on the 15th, it had broken up into at least 4 pieces, and currently it's fading and breaking up as it goes along. So unfortunately the comet didn't come at all. It was a total disappointment. Although the comet was a disappointment, one of my photographs showed this curious effect, and you can see the fuzzy comet at the top of the frame, and obviously a satellite track going through the middle, but what was this curious little scratch? And it wasn't there on the previous photograph or the one following, and it turns out that it was actually a cosmic ray hit. And my camera seems particularly sensitive because I've lost a couple of pixels to cosmic ray hits. And it's interesting that at the moment, because the sun's activity is very low, so there's not much magnetic field in the solar wind, more cosmic rays are actually hitting the Earth at the moment. So it's probably just as well that we can't fly, because we get an increased exposure with the height and with also the more cosmic ray activity. With all the hype over Comet Atlas, it was easy to forget that there are other comets around, and one of those is this comet Pan-STARRS, which currently is around magnitude 8 still. And from this animation you can see its motion in 11 minutes quite easily. And if you haven't seen the comet, then this is a good time to try and observe it, because round about May the 23rd, 24th, it goes within a degree of the two bright galaxies M81 and M82, and eventually ends up in the bowl of the Plough. And then we come to Comet Swan. Now here again, this comet is supposed to brighten to about magnitude 3.5 by the end of May. So it should be a very nicely visible comet, and but we all know about Comet Atlas, so I'm not predicting much. And unlike Comet Atlas, which at least went overhead, this one will be difficult to observe because you've got to get up early in the morning around 3 o'clock, and even then it will only be visible for about an hour before dawn, very low down in the northeast. Currently it's in the southern hemisphere, but as it comes north, let's hope that this one doesn't break up and we'll actually have something good to see for a change. Moving on to the planets, you can't fail to have seen Venus. It's so bright in the west in the evening, and even binoculars now will show Venus as a crescent, and this is a nice picture that Jeffrey took on the 23rd of April. and as the month progresses, Venus gradually draws closer to the Sun, and Mercury is heading in the opposite direction. So on the 21st and 22nd of May, if you haven't seen Mercury before, it goes very close to Venus, so that will aid you in trying to spot it. And then in the following 2 days, the thin crescent moon joins in. So once again, that should make a good photographic opportunity. The other planets are clustered in the morning sky. So here we've got on the left Neptune, Mars, Saturn and Jupiter. And on the 12th of May, the moon joins in. And over the next 3 or 4 days, it moves from being close to Jupiter and Saturn to being close to Mars. And then on the 12th of June, Mars ends up just 2 degrees south of Neptune. So if you haven't seen Neptune before, then that might be an easy way to find it. Looking now at the southern sky at around 10 in the evening, I thought this was a good idea at first, but I'm still a bit dubious given the current climate. But I couldn't resist talking about the constellation called Corona Borealis. So now you see why I was in 2 minds about including it. But it's an easy constellation to spot. It's called the Northern Crown because it's formed from a little coronet of stars, 7 4th magnitude stars, and the brightest one is about 2nd magnitude. But there are a number of interesting variable stars of various types hidden within the constellation, so I'd encourage you to go out over the year and have a look to see if you can see any of the indicated ones varying. Also in the southern skies, the bright star Spica, the 16th brightest star in the sky, and that lies in the constellation of Virgo. Now the main feature of the constellation is in its northern part, which is the Virgo cluster of galaxies. Very bright Messier objects, and this picture shows a close-up view, and of course the most famous of these is M87, otherwise known as Virgo A, because of its strong radio emission, which comes from the active supermassive black hole at its centre. And you can just about see a hint of it in this picture.